What if we poured all Earth's water on the sun? Why getting to the sun is so hard and why it wouldn't cool anything? Okay, Earth is heating up, so someone suggests the ultimate idea. Take all the water on Earth and dump it on the sun. Instant cooling, right? Except this plan fails in 3 different ways. You can't realistically move that much water. Reaching the sun is weirdly harder than escaping the solar system. And even if you drenched it, the sun wouldn't care. And Earth? Earth would lose. Before we do anything, we need one rule of space. Space isn't up and down. In orbit, you're not hanging above the sun, you're falling around it. Earth is already racing around the sun at about 30 kilometers per second. That speed is everything. So the real question isn't, can we throw water toward the sun? It's, can we remove almost all of Earth's sideways orbital speed from that water so it actually falls inward? Earth has an insane amount of water. Oceans, ice, underground water, rivers, even water vapor. Together, it's roughly 1.4 billion cubic kilometers of water. That's 1.4 times 10 to the 9 cubic kilometers. If you turned it into mass, that's about 1.4 times 10 to the 21 kilograms.
Say what?
To picture it, that's a global ocean about 2.7 kilometers deep if it's spread evenly across the whole planet. Now imagine lifting that water off Earth into space and shipping it sunward. The energy cost alone is beyond civilization level. Here's the mind bender. In some ways, it can be easier to send a spacecraft outward than inward. Why? Because going to the sun means you must cancel that huge sideways speed. If you launch from Earth, you already carry Earth's 30 kilometers per second orbital motion. To drop toward the sun, you need to lose a large chunk of that energy. That's why real missions that go close to the sun, like solar probes, use repeated gravity assists. They steal a little orbital energy from planets like Venus, slowly spiraling inward. So even for a small spacecraft, reaching the sun takes extreme navigation, years of planning, and clever gravity braking. Now scale that up to all the water on Earth. You'd need billions of launches, perfect targeting, and a way to keep water from boiling, freezing, venting, or breaking containers during acceleration. And that's before we even talk about cost. Let's do the impossible and assume we somehow deliver it. Would the sun get drenched?
I think you should leave.
No. Near the sun, temperature and radiation are so intense that water would not stay as liquid for even a moment. What happens instead is a sequence. Instant heating. The water becomes superheated steam long before it reaches the surface. Molecules break apart. At high temperatures, water molecules don't stay H2O. They split into hydrogen and oxygen fragments. It becomes plasma. Close enough to the sun, atoms lose electrons. You're no longer dealing with water, you're dealing with an ionized gas, plasma, mixing into the sun's outer layers. So, no, you don't create a giant sun shower. You create a tiny extra smear of hydrogen and oxygen in a star that is already mostly hydrogen. Here's where scale matters. The sun's mass is about 2 times 10 to the 30 kilograms. Earth's total water mass is about 1.4 times 10 to the 21 kilograms. That's roughly a billion times smaller than the sun. So even if every drop reached the sun, you're adding a microscopic fraction to something unimaginably huge. And cooling? The sun produces energy at a rate of about 3.8 times 10 to the 26 watts. That means every second, the sun outputs an absurd amount of energy, enough to out-heat your entire water delivery idea almost instantly. In other words, Even if the water absorbed an enormous amount of heat while breaking apart and ionizing, the sun replaces that energy output continuously. Your cooling effect would be practically undetectable. This is the real disaster. If Earth loses its water, oceans vanish, rain stops, rivers and groundwater collapse, agriculture ends, most ecosystems crash. Even worse, without oceans, Earth loses one of its biggest climate stabilizers. Water stores heat and moves it around the planet. Without it, temperature swings become brutal, hotter extremes, colder nights, and far less buffering. Within a short time, Earth becomes a dry, hostile world, more like a dead desert planet than the one we know. So the irony is, to cool Earth by dumping its water on the sun, you destroy the very thing that makes Earth habitable. So, is it possible? Practically, no. Physics says the biggest obstacle isn't the sun's heat, it's the insane challenge of canceling orbital speed and moving planet-scale mass. And even if you could, the sun wouldn't cool, but Earth would die. If you want a real cooling solution, the only one that matters is here: how we manage heat on Earth, energy, emissions, forests, cities, and technology. Want the next one? What if we moved Earth farther from the sun by just 1%? Because that sounds easier, but it also breaks reality in a different way. Subscribe for the next What If? Comment which planet-scale idea next.